This is problem 2.2.3, and the question is, why do we have the two functions? This is mostly just because it's something that's cool that we can do, so why not? What happens here is, in the real world, sometimes you have practical applications where the probability would vastly change at a certain point. So maybe think of it as like an inflection point or a price point maybe. So the probability of selling a good would be high until it gets to a certain price, and then suddenly it would drop. Something like that. So there's some kind of something happening that causes your probability to change, okay, or another function is now suddenly appropriate. So in this case, what we had is we had two different functions. So f of x equals one thing for x between negative 2 and 0. And then f of x changes to another function for x between 0 and 3, and then 0 otherwise. So you'll notice when we look at our PDF that if we were to graph these two functions, that my PDF is going up, so the probability is increasing, and then suddenly something switches at 0, x equals 0, and now the probability starts decreasing. And so this is why you would have two different functions. As far as what you're going to do for this class, you're going to do basically the same thing, but now if you want to find c, it's just like when we found a, we're just finding that missing constant. You say, well, okay, the integral of f of x dx from negative infinity to infinity has to equal 1. So what you're going to have to do when you integrate this is you're going to say, okay, so if I integrate from negative 2 to 0, 15 over 64 plus x over 64 dx plus, and then I'm going to integrate from 0 to 3, the 3/8 plus the x dx. All of that has to equal 1. So you need to integrate two different things, and when you add them together, that should equal 1. So again, that's the only difference with having your two functions, is that you will have to integrate both of them separately. So now we just have to actually go through and integrate it. So I'll do it one piece at a time. So first I'll integrate from negative 2 to 0 of, let's see, that's a 15 out of 64 plus x over 64 dx. Okay. Let's see, so to integrate this, when you have a constant and you integrate, you get x to the power of 1. So 15 over 64 x to the power of 1. Plus, now this x was before to the power of 1, so to raise it 1 powered, so now we'll have a 2, and you divide by your new power. So we'll do all of that divided by 2. Okay, then you do plus c evaluated from x equals negative 2 to 0. So you plug in your top limit first, so you'll have 15 over 64 times 0 plus 0 squared over, now 64, if you have something over 64 divided by 2, that's going to be the same. 7 out of 16. So that's what I get just for the first piece. Now let's do the second piece. So now we will need to integrate from 0 to 3 of 3/8 plus c x dx. Now it's kind of unfortunate that's a c, and up here I did my big C for integration. They don't really have anything to do with each other. Let's see, to integrate that, when you integrate a constant 3/8, that'll be 3/8x. Plus that c is just some unknown constant, but it is still a constant, and then we'll have x to the power of 2 divided by 2. Again, what I talked about, you don't have to worry about saying plus c if you know you'll have limits, so we'll just go from x equals 0 to 3. So when I plug in the 3 for the top, we'll have 3/8 times 3 plus c times 3 squared over 2 minus, now we'll plug in 0 for my lower limit, 3/8 times 0 plus c times 0 squared over 2. Once again, your zeros just all cancel out, but I do 9 over 8 plus c times 9 over 2. Okay. So for my first piece I got 7 over 16. For my second piece I got 9 over 8 plus c times 9 over 2. So now remember, we're supposed to have, if you add it all up, 7 over 16 plus 9 over 8 plus c times 9 over 2. when we added all of that up, it was supposed to equal 1 because your integrals always have to add up to 1. This should be equal to 1, and now we'll solve for c. So feel free to use your calculator liberally. So let's minus 7/16 and 9/8 from both sides. So we'll have c times 9 over 2 equals, see what is 1 minus 7/16 minus 9 over 8. We get negative 9/16. And now we need to divide both sides by 9 halves. So we'll have negative 9/16 divided by 9 over 2. Again, you can just put it in your calculator. And we get negative 1/8. So c is supposed to be negative 1/8. So remember, we are finding c so that we can have our entire equation of our PDF. So now instead of a c, we can change that to negative 1/8. So let's see what that all looks like down below. So this was our CDF as given to us, and we just figured out that c should be negative 1/8. So after all that work, if we put in a negative 1/8, this will be our final PDF. Now instead of plus a negative 1/8x, you might change it just to make it look a little bit nicer, and you might say minus x over 8 instead of timesing it by 1/8.